go. Right, so from sklearn.model selection, I'm going to import our cross validation score as CVS, cross validation score. We're going to calculate our scores. Cross validation score, give it the model, which is Titanic tree, give it the data that we used, give it the answer, and let's print out our scores straight away. Fab. So it's going to average out around 60%. Let's not do that randomly in my head. Let's actually calculate that. Average, no plural. 65%. That is pretty respectable for a decision tree. It's not bad at all. We're going to try a different set of data now. So we're going to have a look at P-class and age this time and see if that improves it. So that was 60%. I'm not going to print out the decision tree for this. I'm just going to do it in one code block. So the data is now P-class and age. So that's columns 1 to 3. I don't need to reset my answers because my answers stay the same. But I do need to recreate my decision tree. So I'm just going to overwrite my answers from previously. You might have chosen to use a different variable name, and that's absolutely fine. I've chosen to keep the same one. So I'm going to overwrite my answers. I'm going to do a decision tree classifier, and I'm going to fit it to the data and the answer. I'm going to calculate my scores because the point of doing this is to find out if I can create a better decision tree than that. Again, just using 2 columns, nothing else. But is it going to give me better, more accurate answers? Scores equal to my cross validation score, Titanic, and score tree is the tree that's been used, the data and the answer. So that's going to do that 5-way split and do the calculations. And I want to print the average of these scores. Let's run that. 67.9. Let's be generous. Let's round that up to 68. So we've got a 65 versus a 68. Is it any better? Not really. It's about the same. I mean, they're not bad. Really not bad as a decision tree, but I wouldn't say we'd improve this. So we're asked to try with a different version again. So this is P-class and SIB-SPA. So I'm just going to copy this, paste it in, and then alter it. So instead of doing a range there, I'm going to have to type them in because they're not sequential anymore. So I'm going to do P-class and SIB-SPA. My answers are still the same, so I don't need to change that. I'm fitting my Titanic tree on this data and on the answer that we've had before. Calculating the scores and printing out the average scores. P-class, wrong way around. And we've got it slightly better. Let's round up. Let's be generous. 69%. So we've gone from 65 to 68 to 69. This is getting quite good. But again, in the scheme of things, it's not really a huge amount of difference. So you can train on more columns, but you are going to make your decision tree look more complicated if you do that, to the point where you might not be able to actually easily read it, and you might just not actually believe it's going to give you a very good answer. So the last thing I've asked you to do is to pick what you think are the best 2 categories and trial this again with a decision tree. So the women and children first adage is correct for the Titanic. So if I pick to work on if you're male or female and your age, So I can go back to use my include here, which is columns 2 to 4. Answer stays the same. This calculates my decision tree, calculates my scores, and gives me my answer. You can see we can get up to 74% just on 2 columns. And that is pretty amazing. Shows you what a nice data set this is to work with. And I would say that we've now, from our original, we've improved it to the point where I'd say, yes, we actually do have a more robust decision tree that's going to give us a statistically better answer. Right, so the last little bit we're asked to do is to estimate the probability of survival of a person of your choosing. So I'm going to select a person, put them into a NumPy array, 2-dimensional NumPy array. They're going to be 30-year-old and female. Let's run that in. And then I'm going to use this to calculate the probability this person survived the Titanic or not. So using our Titanic tree, the predict probber command, and we're going to put our person into there, and we're going to run that. So if you look at documentation for predict probability, it tells you which order these go in, whether this is survived or died. But basically, it's in the order that you put them in. So this is not survived, this is survived. So you can see a 30-year-old female has a pretty good chance of surviving. And if we change that to male, and it keeps that as well, it swaps around. So they've got a pretty good chance of not surviving. So this data set basically tells you everything you understand about the Titanic is true. But it's nice to prove that with data. So feel free to have a play around with different bits of it. Try some of the different columns, see what you can produce here, and just get to understand that data a bit more. And when you're ready, I'll see you at the next video.